Good morning to all our present here. Myself, Dr. Bharanidaran, Associate Professor, the Department of Artificial Intelligence and Data Science at Panimal Engineering College, and I have 13 years of experience in teaching field. Now we are going to see about the robotics and then the types, and then how it is working principles, and then we are moving to classifications of wheels, and then locomotion, robot locomotion. These are the things we are going to see. This is the agenda what we are going to see. Introduction, and then what is meant by robot, what are the types of robot, and then what are the classifications of robots available, and then we have what are the types of wheels we are available. We have fixed wheel and then centric wheels, and then off-centric wheels likewise, and then we have and then moving to robot locomotion, we have legged locomotion and then wheeled locomotion. And then mobile robot locomotion consists of differential drive and then tricycle and then synchronous drive and omnidirectional. And then summary. Next, what is meant by robot? Robot, there is no precise definition, but general agreements, robot machines with sensing intelligence and predictability. And then the robot can sense, and then it will find out what is going to happen using the sensors, and then get information from its surroundings also. And then it consists of different tasks like locomotion and manipulation, and then it do something physical such as move and then manipulate objects. Next, this is the types of robots. We have robot manipulators, and then we can place a robot as an example for robot manipulators. And then types of robot, we have wheeled mobile robots, we have four-wheeled and then wheeled robots available, and then legged robots also available, and then aerial robots also available. This is the examples of wheeled robots and legged robots. And then this is humanoid robots, and then other robots also available on this page. And then wheeled mobile robots consist of various this is the examples of wheeled mobile robots. And then here we have a combination of very physical and computational components such as hardware and software components. A collection of subsystems consists of locomotion, how the robot moves, and then how it travels around the environment, and then sensors, how the robot measures properties of itself, and then communication, how the robot communicate with each other, and then dynamics is nothing but a study of motion using forces or model, and then kinematics is nothing but a study of mathematics of motions without considering the forces. And then we have rotation, consists of the position, x and y position, and the orientation represent as the theta, where x and y moving the frame, and then x b and y means the base frame. Here it is the x m and then y m. Here we have x b and x b and y represent the base frame and x axis y axis, and then x m and y m denotes the moving frame of the robot. This is a rotation matrix expression as r of theta and as of theta. And then next moving to what are the types of robot locomotion available. First one, robot locomotion refers to the movements of robots from one location to another location using the mechanism like wheeled legs, etc. And then it is important because it allows the robots to navigate diverse environment and perform tasks automatically and interact with some humans or some with the environments. And then moving to the common challenges faced by the aerial mobile robots, we have first challenges battery life, and then energy efficient, and then stability and control. First, in battery life, we see aerial robots, especially drones, require more battery life and are limited by their battery capacity, which can refers to the fight time and then range. Moving to stability and control, wind, rain and other environment factors can affect the stability and control of aerial robots. And then what are the kinematics model in robots, and what are the essential for robot to motion consists of velocities, position, and orientations. And then why the kinematic models are essential for robot motion control. Kinematic model allows the robots to predict in future position and orientation based on the current state and the control inputs. Define the term mobile robot workspace consists of physical area or the environment within the mobile robots can move and separate efficiently. It manipulates all the accessible regions such as a robot can navigate, perform tasks and interact with the other peoples or other objects. Finally, the examples are wheeled legs and then sensors and then layout or obstacles within the environment. Next, moving to what are the LiDAR represents. LiDAR represents a light detection and ranging, and then how it is works depends upon the laser beams to create a high resolution 3D maps of the robot environment. And then what is meant by ultrasonic sensors? Ultrasonic sensors represents the sensors emit sound waves and measure the time it takes for them. Finally, it helps in detecting nearby obstacles and measuring the distance, especially in environments where high precision is not required. In these conditions, LiDAR or ultrasonic sensors. What are the place recognition and why it is important for mobile robots? Deals with identifying and recognize specific locations within the environment based on the sensor input, such as visual features or landmarks and previous experience or maps. Location and navigation plays an important role in mobile robots localization. Here the role of map representation in localization consists of providing a structural framework and what the robot uses to understand and navigate this environment. It acts as a model or blueprint of the robot surroundings. Finally, the map provides reference points of that robots and can use it to compare its sensor data. Examples from camera, LiDAR, light detection, emission within the stored map features. The comparison between the robot estimate its current position and orientation in the environment consists of localization. Finally, we have path localization. With a map, the robot can plan safe and efficient path from its current position to a target location. This is path planning. In other words, the map may include information about the obstacles, restricted areas and optimal routes, and allowing the robots to avoid collision and minimize the travel time. And then we have noise and aliasing in mobile robots localization. Noise refers to the random errors or unwanted variations in sensors data that can be sorted out using the noise robot localization. And the errors can be arise from various sources such as sensors limitations and then LiDAR and then camera, etc. Finally, the impact on localization deals with the noise can lead to inaccuracies in the robot position estimation, causing the robot to disinterrupt its surroundings or make the incorrect decisions for the robot. For example, a noisy sensor reading may results in the incorrect map features or a uncorrected position estimation makes it harder for the robot to decide whether which direction we have to move or not. Finally, we came to an end that what are the robot locomotion and what are the components of mobile robots we have. Finally, last stage we move to types of robot locomotion. Wheeled locomotion consists of robot uses wheels for movements, and then disadvantages consist of high speed, energy efficient, stables, and the disadvantages limited to smooth terrain and requires continuous contact with the ground level. Examples are delivery robots and warehouse robots. Moving to legged locomotion, robots move using their legs. Example, quadrupedal, multipedal, and then bipedal. Advantages consist of can travel here and there from one place to another. Disadvantages consist of complex design, slow movements, and then high energy consumption. Example, we have humanoid robots. Finally, the advantages and disadvantages we seen for locomotion. And then the benefits of the effective navigation in mobile robots have improved safety, energy efficient, time efficiency, and task accuracy. Improved safety consists of avoids collision with the obstacles, and then energy efficiency consists of minimize the energy consumption of optimizing the routes, and then time efficiency ensures a faster task completion, and then task accuracy enables precise movements to complete the task reliability. These are the types of locomotions we have.